here. Ben, thanks again for doing this. I'm not going to go through the background. I think the folks we've already kind of done that in the past. I'll just kind of say, you are a metabolic researcher, been doing that for a long time, and you've had a focus on insulin resistance. Really excited for you guys to know Ben has recently written a book, published a book. I think it's coming out very, very shortly. It's called Why We Get Sick, I believe. Correct me if I messed up the title, Ben, but I got to read an advanced copy, and it's an excellent treatise on basically metabolic syndrome or insulin resistance rather. And Ben is I think I would argue is one of the world's leading experts on insulin resistance, as he's focused much of his career on this. And so there's a lot of sort of debate, about what it is, what causes it, how we treat it. And so, Ben, if you don't mind, and I want people to look at the book, hopefully, because this is a topic that affects, almost all people that have illnesses, at least chronic disease. Can you describe what prompted you to write the book and a little overview of what we'll find in the book in your own words?
Yeah, you bet. Yes. Hey, Sean, thanks again for the invitation. I'm always glad to chat with this very engaged community. And just so everyone knows, I'm not sure if everyone can see this, Sean enjoyed the book so much that he actually, he provided one of the little one of the blurbs for the book. The book, and Sean, thanks really seriously for that. The book it was really intended to change the way we were looking at chronic disease. That sounds a little dramatic. And what I mean by that is, I believe that most clinical markers of the key chronic diseases, so we're talking heart disease, diabetes, cancer, and the like, dementia, Alzheimer's, we could keep going, that they really miss the mark, or they're missing a mark. They're not utilizing what I think should be and could be, it's justifiable, that should be one of the markers for the disease, a better way to diagnose the disease and a better way to track the disease and treat it. And that is namely looking at insulin and checking insulin resistance or some marker of insulin resistance. And it's easy for someone to think, oh, well, Ben's just saying that because that's what he studies, to a man with a hammer, everything's a nail. But the evidence really supports it. Throughout the book, I think I share upwards of 800 citations. This isn't a perspective I've come to lightly. It really is just solely based on the evidence. And even that was a bit of a progression. When I got my teaching assignment, Sean, you'll appreciate this because you would have had to take pathology in medical school. I teach pathophysiology. And so it's sort of it's a slightly different version of pathology where it's a little less of the histology, how the cells look, in say fatty liver disease. And it's a little more of how are the cells acting? How are they behaving? And how is the tissue operating within the context of the whole body when it's sick? So that's pathophysiology. When I started teaching that class 10 years ago here, when I got hired as a professor, I wanted to see how much I could rely on my scientific expertise, namely insulin resistance. And it just kept coming up, whether I was preparing my lectures on fatty liver disease or on Alzheimer's disease or on polycystic ovarian syndrome or erectile dysfunction. Insulin resistance continued to be relevant as I scoured the primary literature. Every time it would come up as at least, if not causing the problem, then accelerating it or exacerbating it. So in Why We Get Sick, I essentially split it up into what is insulin resistance and why does it matter, insofar as it's the most common of all the chronic diseases and it influences all the rest. How do you get it? And then last part is what to do about it.
Yeah, and so, and I guess this is sort of many people in this community will appreciate this, and I appreciate your perspective. And you talk about there are a number of things that can lead to insulin resistance, and there's some out there that claiming that insulin resistance is all caused by excess sugar consumption, carbohydrate consumption. There's others that'll say no, it's all related to obesity and overconsumption of calories. And there's others that are not, that'll now say that no, sugar doesn't matter, carbohydrates don't matter. It's all down to polyunsaturated fatty acid consumption. The fact that we're eating corn oil and soybean oil. And so, what is your perspective on this as someone who's basically life has been dedicated to studying this stuff?
Yeah. So I outline this in the book in much greater detail. Yeah, there are very distinct causes that don't necessarily have to go in sequence, although there can be some sequence to it. But without a doubt, as unfortunately debated as this has become, insulin is a cause of insulin resistance. That is beyond debate. There are multiple studies publishing this, from the whole organism, the whole human body, to individual cells. When there's too much insulin, it will cause insulin resistance. Now, I'm not claiming that that is enough to cause chronic insulin resistance that we would see clinically, but without a doubt, it's part of the cause. Another part of the cause is inflammation in and of itself. We know that when someone is in an inflamed state, they will be demonstrably insulin resistant, and stress as well. That can include even sleep deprivation, anything that is increasing the so-called stress hormones, namely epinephrine and cortisol. Those are very powerful insulin antagonists that are trying to constantly be bumping up blood glucose, whereas insulin is trying to lower them. And so, of course, you have this battle between the hormones and this fight over glucose. So stress can cause insulin resistance as well. Now, so those are all distinct causes. Each can contribute to insulin resistance on their own. And then you mentioned the omega-6 polyunsaturated fatty acids. Those are undoubtedly relevant, but I suspect that's more of that's not going to be a direct effect, if I can say it that way. So whereas insulin, inflammation, and stress, those are direct effects. I mean, we can make someone insulin resistant within hours of intervening with high insulin or stress hormones, or the other one I mentioned, which I can't remember, inflammation, infusing some mild cytokine level. When it comes to the omega-6 polyunsaturated fats, they are going to, do all kinds of negative things. But at the level of the fat cell, they do something bad in this context, which is that it prevents a fat cell from dividing. And someone hearing this might think, well, that's good. I don't want my fat cells to divide. Well, if fat cells are being told to grow because insulin is high, which is absolutely essential for fat growth, there's no getting around that fact. If insulin is elevated and calories are sufficiently available, fat tissue is going to want to grow, and it's going to grow through one of two ways, at least initially. The individual fat cells will grow bigger, so hypertrophic growth, or the individual fat cells will just modestly grow and then they'll start dividing, what we call hyperplastic growth. Hyperplastic growth is a healthier way to get fat, if I can say that without sounding like it's an oxymoron. But that's a person who's getting fatter and yet their clinical markers still look pretty good. So hyperplastic growth is a good way to get fat. Hypertrophic growth is a pathological way to get fat. And omega-6 polyunsaturated fats push the fat cell towards hypertrophic fat growth. And so I say that the PUFA-derived insulin resistance is more of an indirect effect, because it's PUFA dictating the growth of the fat cells. And when a fat cell is growing through hypertrophic growth, its size gets eventually limited. It's basically telling the body, I can't get any bigger. Insulin continues to tell me to try to get big. Now I'm going to become insulin resistant. In so doing, it starts releasing free fatty acids, and then it starts releasing pro-inflammatory cytokines. Those two things start to bleed into the bloodstream, causing insulin resistance downstream, so to speak, in the liver, in the muscle, in the brain. So fat cells are probably, in conventional instances, the first cells to fall with regards to insulin resistance. Fat falls first, then the other tissues follow up. And fat falling first is very likely partly dependent on omega-6 PUFA consumption. So, and that's a long answer. So some direct causes, insulin, stress, inflammation, and then an indirect cause I would submit omega-6 PUFAs, but still totally relevant, all coming in this orchestra or this perfect metabolic storm, creating insulin resistance as we would know it clinically. Now, Sean, actually, I wanted to mention one thing. You and I had communicated offline about branched chain amino acids. And I don't include a section about branched chain amino acids in my book, but just briefly, and I'll defend that just so everyone knows, branched chain amino acids are implicated as a cause of insulin resistance. And this is based on really some very strong correlational evidence in humans, finding that when people are insulin resistant or full-blown type 2 diabetic, they have very elevated levels of branched chain amino acids. And so the idea had been that these branched chain amino acids are causing the insulin resistance. And an alternative perspective on this is that as someone is becoming insulin resistant, the loss of insulin sensitivity at the muscle is resulting in a loss of insulin's defending muscle protein. And so you're constantly in a higher catabolic state at the muscle because insulin can't defend it can't defend the muscle, so to speak. It can't as powerfully activate the anabolic processes. And so the catabolic processes start to win, and muscle is the greatest reservoir of branched chain amino acids. And so the insulin resistant muscle just starts leaking these amino acids. And so it's rather that flipping this paradigm a little bit, an alternative perspective, rather than BCAAs are causing insulin resistance, we could state that the elevated BCAAs are a consequence of the insulin resistance. And I say that because the overall clinical data confirming an order of events, I think is kind of weak, that if we are giving people high levels of branched chain amino acids, they don't just start becoming insulin resistant. Otherwise every bodybuilder would be having a pretty hard time with things. So I believe that the causal evidence is a little lacking, and I think that there's an alternative paradigm to explain its relevance.
Now, would you say we have enough evidence to say there's kind of a final common pathway? I know people talk about it. I know you've talked about the accumulation in various tissues, particularly in regard to ectopic fat, things like ceramides and disoglycerides.
Yeah.
There's, within the realm of the BCAAs, you've got these acylcarnitine things that the compounds that seem to accumulate, and that my understanding is these are incomplete products of mitochondria, oxidation occurring at the mitochondrial level, which causing these storage, the accumulation of these fat compounds, the ceramides and so on and so forth. Whereas we see triglycerides, which many athletes, particularly low carb ketogenic athletes, seem to accumulate without the interference with insulin signaling. So is there a final common pathway at this point? We can say, whether it's inflammation, whether it's hyperinsulinemia, whether it's PUFA consumption, whether it's excess carb consumption or whatever, does there seem to be a final, are we at a point we can say this is what we look at under the microscope and say you now have insulin resistance?
Yeah, that's a great question. No, no, there isn't. But I am going to point the finger at ceramides, and I appreciate you bringing it up. And so the relevance of ceramides is that ceramides are a type of fat, and there are hundreds of thousands of different types of fats in the cell. In biochemistry, it's such an incredibly complicated field of biochemistry. Ceramides is one family where it is known that as ceramides are accumulating in a cell, it will directly antagonize the insulin signaling cascade. So it's immediately fighting what insulin's trying to do. Now, you'd mentioned diacylglycerols. Actually, I actually debate their relevance, frankly, insofar as in my postdoc lab, we would treat cells with ceramides or with DAGs, and the DAGs were not inducing insulin resistance significantly any different from normal cells. But but there's very compelling evidence and some incredible scientists that do that research. So to be fair, let's put them in. What's interesting about both of those, DAGs or ceramides, they are both lipids. And so it lends credence to this idea that many espouse, which is you eat too much fat, the fat is gonna gum up the insulin receptor. And I think you and I spoke about this last time, but it really is just this unfortunate misinterpretation of the evidence. So they, low fat vegan advocates will invoke that idea. You got to cut your fat, and that's going to help your insulin sensitivity. And they base it on that biochemistry, the fact that there are these fats that do antagonize insulin. but it's just not the reality of the situation. Jeff Volek's group, they published a paper finding that in the ketogenic diet, I think it was Volek's group, ceramides, circulating ceramides were actually reduced. And so ceramides are activated when inflammation is up. In fact, that was my whole postdoctoral, all my fellowship work was identifying probably the main pathway for that process. You had to activate inflammatory processes, and then the cell would take a saturated fat and then convert that saturated fat into ceramides. And that would be a direct antagonist. But there's a lot of assumptions when people would say, well, then don't eat saturated fat. Yeah, but it's not that easy. This was definitely Jeff Volek's group. They found that on the ketogenic diet, the group eating 3 times more saturated fat than the low-fat control group, their actual circulating saturated fats were significantly down. So eating saturated fat did not result in an increase in saturated fat. And moreover, their inflammation was further down. And that could be why put someone on a ketogenic diet and they become far more insulin sensitive than any alternative.
But I want to dig down a little more on saturated fats because, you know, we use saturated fats as if they're just this monolithic thing. And when the reality is saturated fats there are numerous different types. They all probably have different effects. I mean, there's long chain, medium chain, short chain, oleic acid, palmitic acid, stearic acid, myristic acid, lauric acid. I mean, are we at a point where we can say this saturated fat may have a different effect than that saturated fat?
Oh, yeah.
And so because, you know, we just hear saturated fat as if it's just one complete thing. And I can tell you that, fat from, palm oil is different from fat from beef, is different from fat from pork, and so on and so forth. Can you comment a little bit on the effects of the different saturated fats, short chain, medium chain, so on and so forth?
Yeah, I'd love to. In fact, what's interesting about all this is that in general, animal fats, I argue that animal fats are best because they cover such an incredible spectrum. They have saturated and unsaturated, and within the saturated family, they cover a broad range of saturated fats, which I'll get to in a second. Whereas the fruit fats, which are the other fats that I consider are ancestral fats, I say animal fats and fruit fats are the ancestral fats. We've been eating them for millennia. Even the fruit fats, coconuts, avocados, olives, but really not as much avocados, coconuts and olives. All we needed to do once we got the flesh out of the coconut, we just had to squish it. We just needed enough of a lever or enough pressure to compress it and we'd get an oil from it. But those fruit fats are much more narrow in their range. Olive oil is mostly 18.1. Coconut oil is mostly, I think it's C12 is the main one, which is a medium chain. So let's get into that now. But in general, long chain saturated fats versus medium chain saturated fats versus short chain, the long chain have a lower rate of oxidation. So the body doesn't want to burn those quite as readily. The body stores them better. Now that's not a bad thing, but the body, if someone were eating an isocaloric amount of short versus medium versus long, the long chain fats are going to get stored more easily than the medium chain fats. And the medium chain fats, although they're not stored much at all, there's still a greater capacity to store those than the short chain. And to my knowledge, the body cannot store short chain fats. They must be burned. And that's why short chain fats are very ketogenic because they demand this kind of priority burning. They go right to the kind of front of the metabolic line and get burned. And then that's slightly less the case for medium chain fats, but nevertheless, they still get burned very high rate. And that's why MCTs are also more ketogenic. And then in general, the long chain fats that we get from lots of sources, but animal fats as well, they're a little less immediately burned and going to be more, have a greater potential for storage. And even within the long chain fats, we know there's a difference between C16 or palmitate and C18 stearate. Stearate actually has a bit of a metabolic advantage, apparently, over C16 palmitate. What's important about that fact, though, Sean, is that stearate is something we have to eat. That comes from the diet. But palmitate, the body makes palmitate very, very well when insulin is up. That is the de facto or the default fat that the liver makes when insulin is elevated.
Yeah, and correct me if I'm wrong, but palmitate has been implicated in the production and accumulation of ceramides in the cell. Is that not correct?
Yep, yeah, absolutely correct. In fact, palmitate is the backbone. Yeah, you're really hitting the nail on the head. It is the backbone of all ceramides. The body will take a palmitate, it'll take the amino acid serine, and when there's a sufficient activation of it, like inflammation, it will induce that sort of coupling. And now we have built on that backbone of palmitate, we have now the higher backbone of all the ceramides that will follow.
And again, just to reemphasize, insulin was a primary lever that kind of dictates the production of palmitate, correct?
Yeah, absolutely. And in fact, we found that even in the absence of inflammation, insulin alone is sufficient to induce the production and accumulation of ceramides in muscle cells. We published that paper about 2 or 3 years ago.
I've dug in and read quite a bit about insulin resistance because I think it's a fascinating topic, and type 2 diabetes and the pathophysiology. There's some talk about differential insulin resistance, that is, liver versus muscle versus fat versus, brain versus other tissues. Is that a real phenomenon? Can we have someone that's insulin resistant in their liver and not be insulin resistant in the muscles? Or is that just a progression? How does that play out in your mind?
Yeah, that's a great question. Yeah, so I'm unaware of evidence in humans or even rodents to really suggest that that we can define where one is becoming insulin resistant and where one isn't. I mean, there is some evidence we can implicate liver very directly by looking at hepatic glucose output, and we can measure that contribution to the blood glucose pool. But I think clinically speaking, I'm going to speculate a little bit here, but the fat will fall first. Like I said earlier, fat cells are probably the first cells to really become insulin resistant. And then once the fat cells become insulin resistant, it's going to, in some order, be the liver and the muscle cells next. But the moment the liver and the muscle cells become insulin resistant, that's really when we start pushing over from insulin resistance into type 2 diabetes, full-blown type 2 diabetes. In fact, I was just revising that lecture for my class for this fall because I got to record all my lectures, no more in-person instruction with a class my size these days with all the COVID insanity. But nevertheless, fat cells go first, and then what flips the switch, as I call it, what flips the switch of someone going from insulin resistance to type 2 diabetes, that happens when the liver becomes insulin resistant and the muscle. Now, and very briefly, I'll start with muscle because it's just the obvious, easiest one. Muscle is responsible for up to 80% of all glucose consumption once we've eaten. If we eat a glucose or a carbohydrate load, muscle will take up to 80% of that. So muscle is the main glucose sink. So if the muscle's having a hard time pulling in glucose, the body's going to have a hard time clearing the glucose. So in other words, glucose is elevated, and that is the definition of type 2 diabetes. Unfortunately, I think type 2 diabetes should be defined by insulin, but conventional medicine says it's glucose. So that's how it checks that box. And then the liver aspect is very interesting because insulin tells the liver to store glucose. It wants it to take in the glucose that it's taking in, it will convert it into glycogen and store it, about 2,000 calories and keep it there for later use. But when the liver becomes insulin resistant, it's not responding to that insulin signal to store glucose. And thus it starts to break down its glycogen and release this as glucose into the bloodstream. And so that's further compounding to this struggle that the person's having towards type 2 diabetes in keeping their glucose in check. So when insulin resistance is happening at the muscle can't pull in the glucose as well, resulting in elevated blood glucose. And when the liver is insulin resistant, it's releasing glucose when it should be storing it, and thus again contributing to elevated glucose levels, pushing the body more and more towards type 2 diabetes. So Sean, I can't give a specific sequence of events, but my little bit of speculation is fat cells become insulin resistant first, then systemic tissues, most notably the liver and the muscle. I didn't mention the pancreatic alpha cells, but I could. That's the glucagon related aspect. And then that's all contributing to the elevated glucose that we'd see with type 2 diabetes. But then other cells become insulin resistant as well, like the brain, In fact, Sean, here's a little spoiler. We are just submitting this week a paper where we did a massive genome-wide analysis in brains from humans, normal brain tissue. So this was all post-mortem, normal brain, and then demented or Alzheimer's brains. The Alzheimer's brains, we detected a broad reduction in genes all related to glycolysis. So in the demented brain, every glycolytic gene we looked at was significantly decreased. So the expression of the genes involved in the breakdown of glucose for energy was all depressed. And then when we looked at all the ketolytic genes of the, I don't know, 12 or so that we looked at, or 15, only one, and in only one specific cell of the brain were the ketolytic genes compromised. So the genes enabling the brain cells, and there are actually more than just neurons there, the ketolytic genes were totally unaffected in these Alzheimer's brains. And I'm getting off on a bit of a tangent, but suffice to say, the brain becomes insulin resistant as well, and insulin facilitates glucose uptake to feed the brain. So, and then we can go through other cells like bone cells, cartilage, they become insulin resistant. The gonads have an altered effect with insulin as well. So it just keeps sort of spilling around the body.
Yeah, I mean, obviously it's going to affect every single cell in our body, I would imagine.
Yep.
I want to,
Yep.
this is because I know that people are like, well, I need a biochemistry degree to understand this stuff for, some of our folks in here, but let me bring it back to a more sort of actionable type thing. So I see a number of our people in this community that have diabetes. We have some type 1 diabetics who are sitting there with an A1C of 4.9. I just saw a guy yesterday said he's off all of his insulin after being on 16 years type 1 diabetic, which I find incredible. I mean, he said he just kept dropping.
Type 1 diabetic, not on insulin?
No, not type 1, said he's just kept dropping his insulin until he didn't need it anymore, which is just shocking to me. So, but, and again, that's obviously a very controversial assertion. I see a lot of people that, there's kind of two versions. There's a more of a protein heavier approach, and there's more of a fat-based approach. And it seems to me that the people that are having the most success with lowering their blood glucose. And again, I know we talked about insulin being the thing, but the blood glucose is often what some people say there's damage occurring, particularly if you're, sustained hyperglycemia. The ones that are going very, very, very high fat seem to have the lowest blood glucose levels right now. So these are the people that are, sitting there with 80–90% of their calories coming from fat. Any comments on what's going on there? And can we look, and somebody's asking, what's the time frame for reversing insulin resistance? Can we look under the microscope and say, aha, you have no more ceramide in your muscle, or some lower level, or how does that, what are your thoughts on the high fat approach being effective?
Yeah. So in fact, Sean, before I answer that, I wanted to make one comment about that type 1 diabetic guy. When I hear that happening, because I've heard that happen from, there's a person I know who lives here in Utah who says the same thing. He's a type 1 diabetic, and he couldn't believe it. He just kept going too low with his blood sugars when he kept his insulin therapy. So he just kind of self-prescribed his way off it, and is doing great. And again, we both acknowledge this is very controversial. We're not advocating anyone doing anything. But when I hear that, I can't help but wonder, is this a case where someone doesn't actually have what we know as type 1 diabetes, and they have something called MODY? And very briefly, for the handful of people listening or who will listen later, MODY is something that looks and acts like type 1 diabetes, where the person has very low levels or undetectable levels of insulin, and thus high glucose and high ketones, dangerously high glucose, dangerously high ketones. And so the person clinically presents and it has all the makings of type 1 diabetes. And what happens sometimes is that they don't actually confirm that the person has anti-beta cell antibodies. In other words, MODY is a type of diabetes where the person has their beta cells. The beta cells are the pancreas. They are there. There's just an absence of one single gene necessary for insulin production. And certain types of MODY, there are like 13 types, they are totally resolved by lifestyle changes, basically a low-carb diet. And that resolves, it is sufficient to overcome that genetic mutation in insulin production. And then they kind of return back to, they're able to go back to a normal life, which is pretty astronomical, really. Okay, so that one comment. And then the fat versus protein, we know that in the diet and how some people have a greater success with fat. I think that is awesome. And I laud anyone who scrutinizes their diet enough to make that change, I think it's just really commendable. We know that protein and the subsequent amino acids can do two things. One, they can have an insulin effect, and two, they can be used as substrate for glucose production in the liver. And I think if someone is coming into a dietary change from the type 2 diabetes state, I do think they should be more open-minded to shifting around that protein and fat a little bit to see what works. And indeed, if someone finds lingering hyperglycemia, as much as I hate to say this, I do say, well, you may need to tone your protein down a bit. And sure enough, I've seen that help people. And again, everyone knows I'm not a physician at all, so I'm not giving medical advice, but I've seen it happen where scaling down the protein a bit and allowing fat to kind of fill that caloric gap, it helped the person, and their sugars did get better. And it could just be because of the effect, the gluconeogenic effect of some amino acids. And then the timeline you'd asked about, we can just base this on actual clinical evidence from Eric Westman's group at Duke. They found that within just 24 hours of someone going on a low carb diet, and of course a carnivore diet would be, I would imagine, even more dramatic, an insulin dependent, I hate to say that, type 2 diabetic, because I don't believe any type 2 diabetic is insulin dependent. So we'll say an insulin treated type 2 diabetic, these subjects had to reduce their insulin load by half within just a day. And then within the subsequent weeks, they would get off their insulin. So people often want to ask, how quickly can insulin resistance get better? I very justifiably say within a day, it can start to get demonstrably, truly, we can detect meaningful improvements in insulin sensitivity within just a day of frankly cutting the carbohydrates. And that's why with my kind of dietary pillars, I like to put that one first. You got to control the carbs, and then we follow up with making sure we're getting protein and fat in higher ratios perhaps than normal, but cut the carbs. And the moment someone starts doing that, their insulin sensitivity starts to get better. And Sean, I do believe that does enable us to point the finger at carbs, as much as I know some people in our kind of low carb community space want to say, well, it's not really carbs, it is seed oils. You don't get such an improvement in insulin resistance just by cutting seed oils within a day. In other words, if we had someone who cut all their seed oils, but they're still eating 60% carbohydrate, that is something, like I said, that's an indirect effect. That's going to happen longer term, but you can cut the carbs, and within one day, we detect true, meaningful, significant improvements in insulin sensitivity. That to me means that if people want to try to equally weight carbs versus seed oils, I think in the long run, that's fair, very fair to do. But in the immediate run, it's not. Cutting the carbs is going to have an immediate effect, whereas cutting the seed oils will not have an immediate effect, as important as it may be.
Yeah, I got another thought I want to run by you. When I doing my reading, and I think it's maybe in both, but certainly in type 2 diabetes. And you point out some of these subgroups, whether it's type 1.5 or MODI, or I mean, I think there's even more. I think there's something like 7 or 8 or 9, 10 classifications. I know there's at least 5 classifications of diabetes now, and probably more being defined in the subclassifications. But one of the things I saw is that the beta cell, the beta cell in the pancreas that produces the insulin, kind of goes through a de-differentiation process. It doesn't necessarily die in some cases. In some cases, we see that the cells have now they've de-differentiated, so they're just kind of a generic cell. They've lost that. Mm-hmm. Are you aware of that? Have you read something about that? Because I know I have read some papers about that occurring, and can it be reversed potentially?
Yeah. So right, there is limited evidence from what I've seen to show that at least in some aspect of diabetes, there is this loss of differentiation. In other words, the cell's forgetting what it's supposed to do and takes some steps back to being kind of a primordial stem cell. In the same vein, there are active researchers, including a collaborator that I have here on campus, Jeff Tessum, a good friend and collaborator. He's looking at genetic pathways to stimulate the differentiation of these stem cells to help induce the production or to become beta cells as a therapy, most especially for type 1 diabetes, but even in some instances for type 2. So yeah, part of the pathology could be, I would say, especially in type 2 diabetes, the cell forgetting what it is, and then being stimulated to go back. And we do see that, this thing called beta cell, like a reversal, of the loss of beta cells in type 2 diabetes, where you can see that beta cells, come back to life. We detect a meaningful increase in beta cell population in the pancreas. I suspect a part of that in type 2 diabetes with lifestyle intervention specifically, I suspect a part of that is perhaps some beta cells kind of remembering what they were supposed to be. They had been de-differentiating, and they make a U-turn and start going back.
Hey, let me ask you about this is often a sort of a thing we hear from folks that say, the critics of the low carb approach to coming off your diabetes meds, normalizing your glucose, no longer the hyperglycemic postprandial response, is that, well, that's all fine and good, but that doesn't mean you fixed your diabetes, because you would fail an oral glucose tolerance test. And my concern is, I'm just thinking back from an evolutionary plausibility. At what point in our evolutionary history would we regularly be exposed to 75 grams to 100 grams of pure glucose in one setting? And I mean, this is, even if you ate a bunch of fruit, you'd still be getting fiber with that. Some of it's fructose, some of it's sucrose, some of it's glucose. When would we normally be exposed to that much pure glucose in our history? I mean, I'm just wondering.
Yeah.
And so what are your thoughts on those people that now we have this adaptive glucose sparing, we have this
Yes.
quote unquote physiologic insulin resistance? Are we not curing diet? Are we not reversing or improving diabetes? Are we just simply masking because we don't demonstrate hyperglycemia anymore, and we're still really sick, like we might hear some of the plant-based advocates say?
Yeah. Well, man, these are such relevant points. So I think you touched on our ancestors. What would our ancestors have been doing to eat that much? As far as I know, it would have only been honey, because even fruits are not the fruits that we know now, right? You look like an apple. An apple is this big sugar bomb. Apples that our ancestors would have found randomly would have been very sour, bitter little things. Not that they wouldn't have been enjoyable. There would have been a little fructose in there to make it enjoyable, most certainly. But I believe honey would have been the only thing our ancestors would have eaten that would have given such a glucose load to even come close to what we do clinically. And I think what's interesting in that regard is that our ancestors would have had to be prepared for battle, if they wanted to get honey. They needed to be prepared for these little bastards trying to kill them for getting in their way and taking their honey. These bees would have been swarming after early man. And so it would have been something I think we did infrequently, and it would have been an absolute indulgence not to be engaged in until everyone recovered from the first bout. So honey would have been, I think, the only source. Now, your point is, I think, brilliant. Insulin resistance is glucose intolerance. That's kind of another version of it, or another way of looking at it. Although glucose intolerance can exist when there is not insulin resistance, and that's what you refer to as adaptive glucose sparing, and we can mention that more. But someone who is insulin resistant is inherently someone who does not metabolize carbohydrates or glucose particularly well. Thus, they must be careful with the carbohydrate. So when someone, to say that, well, sure, the low carb diet helped resolve your diabetes, but it'll come right back if you start eating that same way. Yeah, of course it would. That lifestyle is what caused the disease. And so it makes sense that if you go back to that lifestyle, you'll return to the disease. One of the great myths of lifestyle changes is that someone's going to adopt a change to get to where they want to get, and then go back to eating the way they did before. It just doesn't work. If you have to adopt a lifestyle change to get a sufficient improvement in health, you have to keep that lifestyle change to keep that benefit of health. If someone goes back to their old habits, it makes sense they'll go back to their old health. It's a sad, frustrating reality, but it's the case. So to say that, well, you didn't really cure your diabetes, I would say, well, the lifestyle was the cause of the diabetes. Now the lifestyle is the cure. You've fixed the diabetes by fixing your lifestyle. Now, the idea of someone who's adhering to a low-carb diet going to the clinic and failing the glucose tolerance test, you said it right. It is an adaptive glucose-sparing phenomenon. It is not insulin resistance. I rage against any claim that a low-carb diet causes insulin resistance. And someone who's informed will try to be polite about it or diplomatic, and they'll say, well, it's physiological insulin resistance, so it's not bad insulin resistance. No, that's not. It's not. There is no instance, none, situation of insulin resistance without insulin being elevated. I'm unfamiliar of any situation, and I'll say that again. If someone has insulin resistance, so insulin isn't working well, it is always coupled with hyperinsulinemia, always, invariably. Again, I'm unaware of any situation where that isn't the case. And so importantly, someone who's been adhering to a low-carb diet, they have exquisitely low insulin levels. They do not have insulin resistance. If we were to, now let's split these people up into two groups, or do two things to someone adhering to a low-carb diet. If we give someone who's adhering to a low-carb diet a bolus of insulin, if we just took an insulin needle and injected them with, several units of insulin comparable to what you'd give an insulin-resistant type 2 diabetic, they would die from hypoglycemia. They're so insulin sensitive. So insulin is working extremely well in these people. So they're not insulin resistant. However, if we suddenly load the body with glucose, they are experiencing a temporary glucose intolerance. And why wouldn't they? The body isn't eating glucose. They have trained their body to shift over to this other primary fuel, going from carbs to fat, which is the definition of metabolic flexibility, being able to stop burning carbs to go to burning fat. That's a good thing. I would say, if we're going to say anything kind of controversial here, I think this is more defensible. Someone who's adhering to a low-carb diet long-term actually loses some of their metabolic flexibility temporarily. So very briefly, let me just defend that a little bit. The average insulin-resistant type 2 diabetic person, we say that they're metabolically inflexible because they're always burning glucose. Even if we start to fast them, we measure their energy use in the body after a 24-hour fast, they're still burning glucose. They don't shift to burning fat like a metabolically flexible person does. So a healthy, lean person who's eating carbs, a typical diet, and there are these people out there, they eat a meal, they're carb burning, they stop eating, then they go to fat burning. That's metabolic flexibility. If someone has been in a low carb diet for a sufficiently long time, they are, I guess we could say, so much in fat burning that the body doesn't quite readily shift back to glucose burning once glucose has been loaded into the body. It can, but it's almost like they have this temporary metabolic inflexibility, being stuck in fat burning mode. And so if someone knows they have to go and play the clinical game and do a glucose tolerance test, it is prudent to kind of prime the pump a few days before, start dosing back in the carbs, and then it just lets the body kind of remember, oh wait, you want me to burn carbs now too, because the body hadn't been, because we weren't putting carbs into the system. So carb burning had been dampened. All it takes is a couple days, eat some more carbs, and the body goes perfectly back to carb burning, perfectly fine. So, but to elaborate one last point, there are physiological states of insulin resistance. The most common form of insulin resistance is pathological, like we see clinically, but pregnancy and puberty, these two periods of explosive growth in humans, that is, so pregnant mommy becomes insulin resistant throughout her pregnancy, and she's supposed to. Even a healthy, perfectly healthy pregnant woman will become more insulin resistant throughout the course of her pregnancy. And puberty, that explosive growth, is also defined as you do detect insulin resistance. But in both instances, the insulin resistance is helping grow something. In the pubescent child, it's helping their growth overall. All tissues get bigger. In the pregnant mom, it's helping mom get fat, and it's helping the fetus grow. So in both instances, the insulin resistance is serving a good purpose, but even still, insulin is elevated. So whether it is physiological insulin resistance or pathological, there's always hyperinsulinemia. So to claim that a low carb diet, which puts insulin at very low levels, is causing insulin resistance is on its face not true.
There, obviously, in your book, you prescribe how to sort of rectify or improve insulin resistance for number one. I want to touch a little bit on exercise. Obviously, I'm a big
Yeah.
fan of exercise. I know you are as well. But I've seen some literature out there suggesting that the type of muscle fiber, whether it's type 1, type 2, slow twitch, fast twitch,
Yeah.
high oxidative capacity versus not, they have differential uptake of these fats. They may there may be different responses with regard to disposal of glucose based on the muscle type. And so can you recommend one type of exercise over another? I know there's people like Dr. Bernstein will say that we see improvements in blood glucose disposal with exercise in the evening versus in the morning.
Mm-hmm.
Any thoughts on the differentiation between the muscle types and the different types of exercise and its relative efficacy for improving insulin resistance?
Yeah, it's a great question. Yes, so there are different fiber types broken up into two main categories, with one of them kind of having subcategory. But yeah, the type 1 muscle fiber is a more oxidative. That's kind of the Zach Bitter type of muscle fiber, where it's going to go for a long time. It's lower demand. Not to insult what Zach does, but it doesn't have to put out as much power as rapidly as a period of time, as a unit of time. And so it's just more of kind of the slow burning and indeed fat burning muscle fiber, as opposed to the type 2. Those are high demand. That's more what you do, Sean. It's high power, so a lot of force over a short period of time, explosive movements, and those are predominantly glycolytic. I don't believe that a person has to necessarily worry. In fact, I don't believe someone does have to worry about, are they more type 1 or type 2? There is a genetic component to that, and there is also a training component. But I will say that minute for minute on the low end, like if someone's spending 1 to 2 hours a week, so total time in a week, weightlifting has a better effect than endurance exercise. So resistance exercise elicits a greater improvement in insulin sensitivity. And I think part of that is simply the fact that if you can build muscle, you are expanding the largest insulin sensitive tissue in the body. And so it just stands to reason that insulin sensitivity will get better. So minute for minute, at least on the low end, 1 to 2 hours a week, resistance training is superior. However, I am also quick to say, when someone asks what the best exercise is, it's the one you'll do. And, Sean, so if I'm telling someone to, you really ought to work out like Sean Baker does, they'll look at what you do and say, I'm not going to do that. Or if I say, well, you really ought to work out like Zach Bitter does, I'm not going to do that. And so whatever a person will do, even if it is just a 30-minute or 1 hour walk in the evening, just do it. And the more someone can start approaching something that is fatiguing, going to failure, whether it is sprints or some kind of resistance, then I would say get there. Going to failure is tremendously beneficial, but I don't want to start with that, because that would be too intimidating to someone to think about. It would be a roadblock for them to engage in anything. So whatever the activity someone will do, that's the one to do, or at least that's the one to start with.
Yeah, I'm just going to get to just a couple quick questions that people had here, and then I want to get your, I want to hear, what do we need to do to fix insulin resistance in broad terms. But somebody's asking, back to the fatty chain acids, odd versus even chain. Is there any sort of relevance to that? And then also, I guess you were on a Muscle Intelligence with Ben Pekulski. He was talking about being more effective at expelling CO2, and I suppose it has to do with respiratory quotient, fat adaptive versus not. But can you talk about those two topics quickly, and then give us your prescription for fixing insulin resistance?
Yeah. So odd versus even, it's a little bit of a moot point, just because in nature, the odd chain fatty acids are very, very rare. And so practically speaking, it doesn't really have much relevance. But even still, the body will burn those odd chain fats just like it will an even chain fat. It's just, as we're burning the even chain fats, like palmitate, C16, the most common saturated fat in the blood, it just has a nice, it's tidy accounting where we're burning them off with two carbons are coming off at a time as we're burning the fat. And we're left with 2 carbons, and those go right into the pathway for burning. When it's an odd chain fat, we're breaking off 2 at a time, 2 at a time, 2 at a time. Then we get left with 3. And so the body just has to do a little bit of biochemistry to get off 2, and then you're left with 1 random CO2 molecule. So the body can still burn it perfectly fine. But practically speaking, it doesn't make much difference because we get so little of it in our diet. Then with regards to CO2, I need to be a little careful because I'm not as well versed as maybe I ought to be. But the idea, when Ben and I were discussing that, what came up was this idea of enhancing the body's CO2 tolerance as a way to control, frankly, as a way to control anxiety, partly, and activation of the parasympathetic nervous system, this idea of kind of settling the body down. And to Ben, who is, of course, an avid bodybuilder, the idea is I want to get into this parasympathetic state in order to recover. And that makes sense. Post-workout or in the evening or whatever, when someone wants to recover, the parasympathetic nervous system is going to be the nervous system that predominates that recovery state. But the having a greater CO2 tolerance, I don't believe is going to have any real effect on metabolism, on nutrient biochemistry. I think that's really not the point of controlling CO2. Indeed, it won't have an effect to any real degree. I'm certain of that. The idea is you enhance your CO2 capacity so that you can control breathing, heart rate, basically parasympathetic. You settle the body down. And in fact, I confess that was my initial interest. I was going through a period of time as a kind of being a new dad, and I still am a dad of quite young kids. Well, my youngest now is 7. But all of the stresses of life, fatherhood, being a husband, it was weighing on me. And I found that controlling my breathing as outlined, and I will recommend the book, but don't read my book first, everyone. Don't buy this guy's book first. Get mine first. Well, get Sean's first, then mine, and then this guy's. It's called The Oxygen Advantage. I'm just looking up on my shelf. Yeah, Oxygen Advantage by Patrick McKeon. It's pretty compelling. It's really interesting, and I appreciated a lot of his perspective. But again, buy my book first. And then my thoughts on, speaking of my book, my thoughts on how to improve insulin sensitivity. In the book, I presented it as, I tried to be as objective as possible and just look at all the evidence encompassing on one end a low-fat vegan diet and on the other end a carnivore diet, because we can all agree those are the extremes and everyone else is falling somewhere in the middle of that. I believe that if you take the average American, or indeed in any country, because insulin resistance is everywhere these days, and you put them on either end of those spectrums, they're going to have some improvement in insulin sensitivity, especially in the short term. You do anything to depart from the conventional standard American diet, they're going to have an improvement in their insulin sensitivity. Now, I am quick to add, the more someone is eschewing animal products, the more they will most certainly have nutritional deficiencies that will cause other diseases. So they may be improving their insulin resistance, but they're going to die from 2 different types of anemia, to say the least, not to mention other problems. So if someone, what they have in common though, is that they're both avoiding processed foods. The combination of refined starches and refined seed oils, which is really the bulk. In fact, speaking of seed oils, we eat more of our fat from soybean oil than any other source of fat in the diet. I mean, that is a telling revelation with regards to the modern human diet. So the moment someone is cutting out processed foods, they will start to have improvements. And I believe that is what a vegan diet and a carnivore diet can have in common. Now, I will also say, you can be a vegan and eat a lot of crap. There's a lot of junk food that will fit into that vegan category, whereas there is no junk food that will fit onto the carnivore end of things. In fact, Sean, I'm joining you for the Just Meat July. I do it every January, and now I'm doing July as well. So nevertheless, not to, that may be revealing too much of my bias, and I don't mean for it to, but with carnivore, one of the big beauties of it is you're going to get everything you need, you know that, and then two, there is simply no room for junk food. It doesn't fit. Whereas vegan can be a lot of junk, frankly, and it will be nutritionally deficient. There's absolutely no debating that. So that's my general thought is, I kind of broke it up into 4 pillars in the book, and as follows: 1, control carbohydrates; 2, prioritize protein, high quality protein, make sure you're getting it, and that is animal in every instance. Plant protein is inferior in every way, and we can elaborate on that if you want later, but everyone here knows that. 3rd, fill all the remaining calories with fat. Don't be afraid of eating fat. And then lastly, especially if someone's coming into this as a type 2 diabetic or known insulin resistance, intermittent fasting, or, watch the clock. It is incredibly therapeutic. And we really have to credit Jason Fung, I believe, for really the birth of the modern fasting interest. As controversial as that may be in some circles, I think it's unfortunate. If someone is insulin resistant, fasting is incredibly therapeutic. And so even if it's just on the ends of the day, breakfast or dinner, not even full day fasts, I think there's really value in just giving the body a break from eating and forcing the body to use its own fuel. So those are my 4 pillars with regards to improving insulin sensitivity.
Yeah, just a comment. There's a book out there called Mastering Diabetes. It's written by Cyrus. I can't pronounce his last name, but he's a vegan advocate, and basically, and I've read the book. It's got, I like to get different perspectives, and he is basically recommending an incredibly low-fat diet. I mean, it's something like a total of less than 20 grams of fat per day, which is incredibly challenging to do. And incredible high amounts of carbohydrate. I mean, it's unlimited, as much, fruit and carbohydrates as you want. I mean, there's you can just unlimited amounts, you could eat 100 bananas in a day if you felt like it. And they say they are getting results, and their main metric is, and these guys are type 1 diabetics, and they're, sorry about the dogs, and their metric is your amount of glucose you can consume versus how much insulin you need to utilize with that. And so it's a different perspective, and their justification is, well, we want somebody that wants to be able to eat carbs to do so. And so it's just saying that if you're going to eat carbs, and you have to reduce your fat so low, almost to I would argue almost to a dangerous level or an untenable level. But I mean, that's an interesting, we talk about the 2 ends of the spectrum, and there's a doctor, Tony Hampton, who I just kind of snapped a tweet. He said, he's been practicing medicine for 22 years. For the first 17 or so, he prescribed a low-fat vegetarian diet. He got maybe 1 or 2 people off medications.
I saw that.
In the recent times, going on a low-carb, high-fat diet, he takes several people off a week. So there is a maybe where both sides work, but maybe one side works better. And then so back to your prescription. I wonder if you talk about intermittent fasting. Is there a role for extended fasting? And then are there any supplements? And I know a lot of people talk about apple cider vinegar, cinnamon, berberine, alpha lipoic acid. Do you have any comments on those things? Are they just, icing on the cake, so to speak, or are they a waste of time, or do they have any efficacy?
Yeah, so there are these kind of finer molecules can help, but so cinnamon, for example. Cinnamon can improve insulin sensitivity. If someone has some known mineral deficiencies, like chromium deficiency can cause insulin resistance due to the relevance of chromium in just the biochemistry of insulin signaling. So if someone has a known mineral deficiency, that will result in immediate improvements. There are certain vitamin deficiencies that also can improve when it's supplemented, like vitamin D. I will say that macronutrients deserve first priority. That someone, if they're looking at getting berberine or alpha lipoic acid or cinnamon, but they're still eating the same conventional diet, it won't do a thing. If someone's adopting changes in their macronutrients, like I outlined, and they still see that they're not getting, or they're getting an improvement, but they want to just get a little more help, then I do believe the evidence is there to support things like, apple cider vinegar, cinnamon, and vitamin D and so on. So those things are relevant, but I think they're a secondary category. The primacy must be placed on the macronutrients, the big parts, and then everything else is like you said, that's icing on the cake. That's going to be just a little bit of extra help, but the evidence is there. These things do help, but it's going to just be very minimal in comparison to adjusting macros. But yeah, Sean, with these guys that are promoting a vegan diet, the evidence, I mean, if you compare a vegan diet to a conventional American diet, it will get better. That is published data. The question is, what if you compare a low-fat diet to a low-carb diet? That has also been asked, and the low-carb diet wins. I would not advocate a low-carb diet if that data weren't there. I see human health through the lens of insulin resistance, and my primary aim is asking, how can we nourish the body, most optimally nourish the body while addressing insulin resistance? I don't believe it's justifiable to say a vegan diet. A vegan diet may address the insulin sensitivity if done with whole foods, but it will not address sufficient human nutrition in all its complication. A vegan diet is deficient in a person. Speaking of supplements, I joke. Well, not a joke. A vegan diet is a privilege of the elite. You have to be educated enough to know what you're deficient in, because you will be, and you have to be able to afford the proper supplements to make up for that deficiency. It is just so arrogant and smug to claim that everyone should be on a vegan diet. I think if someone had those two things to overcome, if they knew what they're deficient in and they're making up for it with supplements, all right, you will live and you can probably get by. But to claim that everyone should be doing that, oh man. And those are bigger hurdles than people think. There are people who believe they're very well informed vegans and supplementing, and they still have disastrous health. So these guys that are claiming that the vegan way is the way to go, I'd say, yeah, if you're strictly looking at insulin sensitivity, you will get an effect, but you're ignoring human nutrition in other ways that are disastrous. And so being smart about the carbs and being liberal with the protein and fat, that's the way to go. And Sean, how crazy to base a diet on the one macronutrient that is not essential to humans. That's just bonkers to me.
Yeah, can you just, because that's a statement, it's, I mean, obviously here, but I mean, this goes out to recording. Can you sort of expand upon that, the one macronutrients that's not essential? I mean, obviously you're playing carbohydrates. Why?
Yeah.
Because we're told that, you know, carbs are essential for brain function. You know, many dietitians will tell us that, you know, you need 130 grams of carbohydrate per day to run the brain. You know, your thyroid will just be destroyed without carbohydrates. You know, if you don't have, you know, fiber is a different battle. But anyway, can you expand upon that? What is it? Because I've read a biochemistry textbooks. I know the answer, but can you maybe?
I know you do. Yeah, you're giving me a slow pitch here that you're going to let me knock out of the park. I appreciate that. Yeah. So a lot of the nuance here is lost when people say it the way you did, and people do say it that way. You got to eat the 120 grams to feed the brain, or glucose is essential or carbohydrates essential for the brain. That's not true. It's glucose that the brain uses. So a lot of what people are relying on is just that the average listener not being savvy enough to catch the error in what's being stated. The body can make all the glucose that it needs to perform all its functions. To whatever degree the brain absolutely needs glucose, and that we don't know, then the liver can provide that glucose. To whatever degree the red blood cells, which absolutely demand glucose, however much glucose they need, all the red blood cells, the liver provides it. And so that is why we say that carbohydrates in the diet are not essential, because the glucose that is essential in the blood, the body makes it. The body can get it on its own, thus making dietary sources of glucose not essential. And again, because blood glucose is needed, it is absolutely essential. Blood glucose is, and the body has a way to make it. In contrast to the essential amino acids and the essential fatty acids, those are essential because the body cannot make them, and yet every cell in the body needs them to function properly. that we cannot say that with regards to dietary glucose. There's nothing essential. And even the most dogmatic dietitian has to reluctantly admit that. If they're educated at all, they will reluctantly admit, yes, carbohydrates are not essential. Then they'll go on to elaborate all the benefits as they perceive them. And I'm not saying there can't be some things that can help, but they are not essential. And I think our human diet is so wrong because we are, one, focusing on the one macronutrient that is not essential, and two, it happens to be the macronutrient that has the biggest effect on insulin, driving insulin resistance. And that's why insulin resistance is the most common disorder in the world.
Yeah, I'm sure you're familiar with the work of Professor Grant Schofield in Auckland, New Zealand, talking about hyperinsulinemia, which kind of, as you say, is a component of this. Ben, I want to be mindful of your time, and again, I sincerely appreciate you coming on. You're always a wealth of knowledge, and it's a pleasure to talk to you anytime because you answer so many of my questions, and I think hopefully we get into some of the nuance. And there's so many, I'm sure, as you know, the farther you dig down the rabbit hole, you find there's more and more nuance. And I just find that people making these proclamations about we know it all, we don't need to do any more science, to me, to be kind of scary and not very scientific. Where can people find your book? When is it out officially? Is there going to be an audio version? Is it available worldwide? Give us the details on that, because I read it. It's a wonderful, wonderful book. I think everybody should have it on their shelf, particularly anybody that is dealing with any chronic disease, and share it with your family members, because you write it in a way that is, as much knowledge and complex science you can talk to. You write it in a way that's very accessible, which I appreciate as a dumb orthopedic surgeon, being able to do that stuff. But I mean, everybody else will too. And like you said, literally every sentence you wrote in there, I think, had an attached reference. I mean, it was just like reference after reference. It's just the facts. It was kind of a Joe Friday dragnet. These are the facts. And I think it'd be hard to argue. You're
dating yourself, Sean. You're dating yourself. If you're invoking dragnet.
Well, he even predates me, but I'm old enough to remember my, the parents' generation. But anyway, let us know about how to get hold of that book.
Sean. Thanks again. Yeah, you guys, everything you want to know about insulin resistance, I really made an effort, and including a little quiz that you even start the book with, just kind of know where you're at, or where your loved ones are at with regards to this problem. And frankly, chances are it's you, without a doubt, someone who's got this if you don't have it yourself. And the book is available anywhere, pre-order. So Amazon, Barnes and Noble, the usual suspects. And really, it helps frame this conversation that someone can either have with themselves, some kind of practical takeaways to know where they are, what their risk is, and what to do about it, including a lot of substance that they can take to their primary care physician. Because Sean, as you know, in the medical field, everyone, physicians included, we only know what we've been taught or what we've taught ourselves. And so people will often say to me, "Oh, Ben, isn't it just so crazy how many physicians don't know about this?" I mean, it's crazy, but I don't say that in an insulting way. A physician only knows what he or she has been taught. It's silly to expect them to know something they haven't been taught. And medicine, a physician gets paid to see patients. They don't get paid to scour the literature. Sean, you're a bit of an anomaly with how much time you've spent diving deep into the literature, because you don't get compensated for it. As a scientist, it is my great privilege to get paid to be curious. Now, I don't get paid that well, so buy my book, everyone, and help out a poor professor. But being a scientist is cool because I get paid to be curious, and that is a cool thing. And so I have the time to sit back and answer questions that a physician doesn't have. And so if there's information in this book that a patient can take or share with the physician, oh man, that's one of my greatest hopes, is that this can help be a small part of changing the conversation, at least with regards to any disease that stems from metabolic problems. And frankly, there are a lot of them. So the book is available anywhere books are sold, and it is released so that I think it will be shipped and received on July 21. So, and that's the release date. I think that means it arrives on July 21. And so that's just a couple weeks. So the day is fast approaching.
Yeah, well, certainly I hope that it does well, and I suspect it will. I mean, I think it'll help just a tremendous amount of people.
I see someone's asking, here's the book, Why We Get Sick. I should have mentioned it again. Sorry, I'm not selling it very well. Why We Get Sick on Amazon. There are a couple other books with that title, unfortunately, but they won't have the author, Ben Bikman, the one and only.
Yeah, it was kind of funny when my book came out. There were other S. Bakers that wrote the book. This is kind of funny that people just trying to jump in on that and catch the little side effects on that. Awesome, Ben. Any plans in the future to do any research on human beings anytime? I mean, we've got some. I think, like I said, I know we've got a community that would probably be welcome if you need volunteers that would be willing to participate in some of that stuff.
Yeah. So Sean, I realized that you'd asked about audiobook. Yeah, there is an audiobook. I chose the guy who did the reading, and he was great. He kind of sounds a little bit like me, just not quite as nasally, but still kind of energetic conversation. So his voice is me, but better. The human studies, yeah, we are actually starting more and more humans. And that's kind of derived from my frustration of being a metabolic scientist, and yet everything I've been doing is cells and rodents. And I just have been really pushing to want to get to that next stage into humans. We have under review right now the study we've been doing for over 2 years, which is looking at the effects of ketones on fat cell. And that included human data where we were pulling fat biopsies from people in and out of ketosis. We're actually starting a new project. I can't believe I'm saying this, but it's looking at the effects of near infrared light. You know this, in fact, it's with this company who's providing the equipment called Joovv, Joovv. I'm very cynical about, I'll say skeptical about these kinds of things. Not that I think sauna can be very, very beneficial. I'm a huge advocate of sauna and go down to the sauna here on campus every day. But this was based on a study from rodents that when they exposed rodents to this light, it stimulated mitochondrial uncoupling, which is what we were looking at with ketones. So the idea is we're going to get humans on day 0, take a fat biopsy and look at the metabolic function from the fat cells. On day 30, after 30 days of this light exposure on their belly, where the fat is that we're taking for biopsies, we'll do a follow-up biochemistry and look at the fat cell metabolism. And then we're also wrapping up a study looking at rates of ketogenesis in a fast when someone exercises at the beginning of a fast or doesn't. And long story short, it does accelerate ketogenesis, and it increases glucagon much more significantly as well. So the insulin to glucagon ratio is better when a fast starts with exercise. So yeah, more and more human data, more to come.
Wonderful. Well, thank you again, Ben. Appreciate it. Have a great week, great summer, and enjoy your Just Meet July. That's cool that you're doing that. And hopefully,
I'm joining the tribe for the month.
Joining the group for that. All right. Well, thank you so much. Have a great day, guys. Thanks for coming by, folks.
Thanks,
and this has been wonderful. Good luck with the book. All right, everybody, take care, and we'll see you tomorrow.
Thanks, brother.